My name's Lauren Bass. I'm in Catherine Burns' Physical Science Lab, and I will be recording for my lab number 2. We were asked to measure the length, width, and height, and then calculate the volume and the densities for a Milky Way bar and a Snickers bar. And I actually did the equations on a different day, and so I no longer have the candy bars, but I will be saying how I calculated those. For the length in centimeters, for the Milky Way bar I got 9.2 centimeters, and the Snickers bar was 9.9. The width for the Milky Way was 3.1. Width for the Snickers was the width for the Milky Way was 3.2, and the Snickers was 3.1. The height was 2.1 centimeters for the Milky Way, and for the Snickers was 2.0. To calculate the volume, I just calculated length times width times height, and for the Milky Way I got 61.8 centimeters, and for the Snickers I got 61.4. The mass of the wrapper in grams for the Milky Way was 52.2, and for the Snickers it was 52.7 grams. The mass in grams was 52.8 for the Milky Way and 54.1 for the Snickers. To calculate the density, I use the formula density equals mass divided by the volume. So for that, I did 52.2 divided by 52.8 for the Milky Way, and I got 0.85 for the density. And for the Snickers, 52.7 divided by 54.1 and got 0.88. After I cut the candy bars in half, the two halves for the Milky Way, the lengths were 4.2 and 4.1. For the Snickers, 4.4 and 5.1 centimeters. The width for this Milky Way was 3.2 and 3.1, and for the Snickers 3.3 and 3.1. The height for the two different halves for the Milky Way were 2.1 and 2.0, and for the Snickers 1.8 and 1.9. To calculate the volume for the candy bar halves, I multiplied 4.2 times 3.2 times 2.1 for the first half and got 28.2 centimeters. For the second half, 4.1 times 3.1 times 2.0, I got 25.4 centimeters. For the Snickers, I did the same thing. I calculated 4.4 times 3.3, and times 1.8 for the first half, and then 5.1 times 3.1 times 1.9 for the second half. And the first half I got 26.1 centimeters. The second half I got 31 centimeters. I'm sorry, that's for the volume. The mass for those, for the first half it was 26.3. The second half, 26.3 for the Milky Way. For the Snickers, I got 25.2 grams, and for the second half, I got 28.9 grams. To calculate the density, I divided the mass by the volume again. And for the first half on the Milky Way, I got 3 as the answer, and for the second half, I got 1.04. And then for the Snickers, the first half I got 0.97, and the second half 0.93. The average density, I added the two halves and then divided them by 2, and for the Milky Way I got 0.99, and for the Snickers 0.95. And then for the questions, on number 2, Looking at the results of your experiment, what happened to the volume, mass, and density of the candy bars after you cut them? The volume was lower, and there was a 0.2 gram difference in the Milky Way, but the rest stayed the same. And then the average density is higher for both candy bars. Number 3, the density of aluminum is 2.7 grams. If you cut your sample in half, what would happen to the density of that sample? It would increase, just like it happened in the experiment with the candy bars. Number 4, the density of liquid water is 1 gram divided by centimeters cubed. If you place the candy bars in a tub of water, what would the candy bars do and why? They would sink because they absorb the water. Which candy bar was most dense? In the Snickers. And why do you think one candy bar was denser than the other? What's the reasons behind this? The Snickers has more to it. The nuts and the peanut butter are what make it denser. And number 7, please write a paragraph for your conclusion. Discuss your findings, what you learned, possible mistakes, how you would change what you did to improve your results. I just wrote the candy bar weighs more than what the package says it does. Some of the calculations could be off, so just going over it a couple more times, maybe making sure everything's really precise, that would be able to improve your experiment.